finally touched down. At 12 a.m. ET on Saturday, the 9th of September, Boeing Starliner landed safely at White Sands Space Harbor in New Mexico, ending 12 weeks in space, despite what was deemed a safe re-entry. As we can see, propulsion issues on the Starliner continue to persist. So, should we consider this a successful landing of the vehicle? Find out everything in today's Techmap episode. But before we begin, let's subscribe to the channel to stay up to date with the latest space news. At 6:04 p.m. EDT on September 6th, Boeing's uncrewed Starliner spacecraft was undocked from the International Space Station. Engineers used Calypso's forward thrusters, avoiding the problematic thrusters that had previously malfunctioned. As a result, the undocking process went quite smoothly, except that as Starliner was backing away from the station, one of the thrusters did not fire as expected. In NASA's words, although this means a slight loss of redundancy, it shouldn't keep Starliner from getting through re-entry and landing as expected. About 4 hours after undocking, Mission Control confirmed Starliner had completed its deorbit burn and jettisoned its service module to burn up over the Pacific Ocean. Starliner's crew module, without its crew, continued to fly by itself, heading for a landing in New Mexico to avoid any potential risk. The Starliner crew module uses a different set of thrusters from those that caused trouble during Starliner's flight. But another problem happened, as one of the 12 control thrusters on the crew module failed in a test earlier in the evening. A single thruster failure isn't expected to be an issue for entry. Luckily, at 12 a.m. ET on Saturday, Starliner landed at the White Sands Space Harbor in New Mexico. NASA astronauts Barry Butch Wilmore and Sunita Suni Williams will remain on board the International Space Station as members of Expedition 71 70 seconds before their return on board a SpaceX Crew Dragon spacecraft no earlier than February 2025. Despite being deemed to be a safe landing, as we can see, there are still thruster problems that happen during the journey. NASA might have predicted these problems. Thus, Starliner's departure from the station was set to be different from what was originally planned when it would have astronauts on board. The spacecraft would make a relatively rapid departure from the vicinity of the station, called a breakout burn, rather than a more gradual separation that would include a fly-around of the station. This maneuver was designed to minimize stress on the thruster, particularly the aft-facing ones that had experienced problems in June. Once Starliner is away from the vicinity of the station, though, controllers plan to test fire several of the thrusters. NASA's Steve Stitch said engineers were still choosing what thrusters to test, but that they may involve some of the aft thrusters that experienced problems, including one that appeared to lose all thrust on approach to the station and did not recover in subsequent tests. Those tests would be short pulses, lasting about 0.1 seconds, which would be enough to see how well they were forming. The purpose of that is to continue to learn, he said, collecting data in addition to tests performed while Starliner was docked to the station. We really want to see how the thrusters perform and what the thrust levels exactly are after we undock and fire them for a little bit. This comes from the failure to understand the root cause of the spacecraft issues, even though previously both NASA and Boeing spent weeks testing and analysis. These stretched Williams and Wilmore's stay from the expected length of about 8 days to months. And even if the problems were understood, that didn't mean things would get much easier. The Starliner team would never get to inspect the propulsion system on the actual vehicle in space. It was impossible to survey the problem as the Starliner sat attached to the space station. More terribly, the service module, which houses the troubled RCS thrusters and the helium leaks, was not intended to survive the trip home. Instead, it was jettisoned and burned up upon re-entry following Starliner's deorbit burn. This explains why they have to keep the spacecraft in space longer to get access to the existing service module. Unfortunately, hard work doesn't pay off. The ambiguity surrounding what exactly happened to the service module's components was one key factor in NASA's decision to fly the vehicle home without its crew. During its perilous return to Earth, Starliner does have other types of thrusters meant to help the vehicle keep its orientation as it travels through space. The RCS thrusters were used again to maintain attitude control during the deorbit burn, which was carried out by larger thrusters. The RCS thrusters maneuvered the spacecraft after that burn to separate the crew capsule from the service module and orient the capsule for re-entry. Alongside the 28 RCS thrusters are 20 orbital maneuvering and attitude control, or OMAC, thrusters, each of which has about 17 times the thrust of an RCS thruster. But what if helium starts to leak in that case? NASA's Stitch described how the problems already identified on the Starliner's service module might combine to create a disaster scenario. The worst case would be some integrated failure mechanism between the helium leaks and the RCS thruster, he said. For a nominal deorbit burn, we fire 10 OMAC thrusters in each of the 4 doghouses, and then the RCS jets are just there to hold the orientation. He added that if OMAC thrusters began failing because of helium leak, a bleak outcome could arise. Then you could end up with some cases that aren't easily controlled. And that's really the more stressing cases that the team is worried about. With Starliner safely back on Earth, NASA will now turn its attention to certifying the vehicle for crew rotation missions. It includes addressing the thruster problems as well as helium leaks. We've been entirely focused this summer on understanding what is happening on orbit, trying to decide if we could bring the crew back or not, Stitch said. What we need to do now is really lay out the overall plan, which we have not had time to do. At the pre-return briefing, NASA did not indicate how long post-flight reviews of Starliner and corrective actions might take, or if Boeing would be required to perform another test flight before certification. To be certified for the first of 6 operational crewed missions, Calypso must be reliable first. Any issues with its propulsion system and even other components have to be thoroughly addressed, but that will be difficult for a contractor known for a decade of persistent technical problems and a flawed operating system. Of course, they really need a major overhaul. And of course, no one knows how long that will take. This is something NASA is concerned about, and the national agency has yet to decide whether to require Boeing to conduct another test flight to ensure safety before officially certifying Starliner for operational missions. Any answer that involves a yes or no comes down to a trade-off between safety and time. Aside from the decision on another test flight, to receive full contract money, Boeing has to complete 6 missions under the contract. However, only 3 of the 6 missions are currently confirmed to be ordered. Theoretically, NASA awards these task orders about 2 to 3 years prior to a mission's launch. As a result, Boeing can only complete a maximum of 3 missions in 6 years, before the ISS retires in 2030. On the other hand, if the space agency allows Boeing to prepare for any Starliner missions beyond the 3 already on the books, this would conflict with NASA's current plan, as SpaceX intends to bring online a new 5th Crew Dragon for its fleet next year. The U.S. Space Agency intends to order more Dragon missions, along with 14 extended missions of SpaceX's commercial crew contract. So they just need the handful of Starliner flights already on order, which is enough to keep the ISS fully staffed through 2030. Anyway, Calypso's safe return is still a blessing for Boeing itself. Thanks to that, the company will have more evidence to persuade NASA engineers that Starliner is good to go for crew rotation flights once Boeing resolves the thruster problems and helium leaks. Continuing the Starliner program could help Boeing earn $1.9 billion in potential revenue from NASA. Of course, that $1.9 billion is of the $4.6 billion total potential value of its commercial crew contract. As you may know, NASA awarded the company an initial $4.2 billion contract in 2014, and contract modifications since 2014 have added $400 million to the deal. So far, $2.7 billion has been paid out, while $1.9 billion remains to cover future service payments for operating flights. The $1.9 billion figure is still more than the $1.6 billion in losses the company has incurred on the program to date. According to the plan, the Boeing Starliner spacecraft is going to undock and conduct an unpiloted return to Earth overnight on Friday, September 7th, in the final chapter of a disappointing test flight. On Thursday morning, an account named Ed Van Cease, which supports ops on Space Station and Boeing Space Starliner, shared, "My team and I worked with Butch and Suni to finalize the configuration of the return cargo in Calypso this morning. This afternoon they will do a final check of the cabin and close the hatches between it and Space Station. Still on track for undock and landing tomorrow evening." Regarding the undocking software problem, he added, "There was never an issue with the software, and we don't have to update the flight software to fly without the crew. We changed a couple of configuration settings that get used after touchdown, and that's it. And those are only used in just-in-case scenarios." Boeing later announced on X, Starliner's hatch is closed, and teams in Houston are preparing the spacecraft to leave the space station. Undocking coverage begins at 5:45 p.m. ET on September 6th, with a landing planned for roughly 12 a.m. ET on September 7th. For Starliner missions, NASA and Boeing will use potential landing locations in the White Sands Missile Range, New Mexico, Wilcox, Arizona, and Dugway Proving Ground, Utah. Edwards Air Force Base in California also is available as a contingency landing site. 24 hours before undocking, NASA analyzes weather predictions for the various. When teams proceed with undocking, Starliner will complete a series of departure burns, allowing it to reach its landing site in as little as 6 hours. A final weather check also occurs before the spacecraft's deorbit burn. Once clear to proceed, Starliner executes its deorbit burn, which lasts approximately 60 seconds, slowing it down enough to re-enter Earth's atmosphere and committing the spacecraft to its targeted site. Immediately after the deorbit burn, Starliner repositions for service module disposal, which will burn up during re-entry over the southern Pacific Ocean. Following service module separation, the command module maneuvers into the re-entry position. During re-entry, the capsule experiences plasma buildup, reaching temperatures up to 3,000 degrees Fahrenheit. That may interrupt communications with the spacecraft for approximately 4 minutes. Once Starliner re-enters Earth's atmosphere, the forward heat shield, located on the top of the spacecraft, is jettisoned at 30,000 feet, exposing the 2 drogue and 3 main parachutes for deployment. The parachutes will continue to slow the spacecraft down as the base heat shield is jettisoned at 3,000 feet, allowing the 6 landing bags to inflate. At touchdown, the spacecraft is traveling at approximately 4 miles per hour. The NASA and Boeing landing and recovery team is stationed at a holding zone near Starliner's intended landing site. After landing, a series of 5 teams move in toward the spacecraft in a sequential order. The first team to approach the spacecraft is the Gold team, using equipment that sniffs the capsule for any hypergolic fuels that didn't fully burn off before re-entry. They also cover the spacecraft's thrusters. Once given the all-clear, the Silver team moves in. This team electrically grounds and stabilizes Starliner before the Green team approaches, supplying power and cooling to the crew module since the spacecraft is powered down. The Blue team follows, documenting the recovery for public dissemination and future process review. The Red team, which includes Boeing fire rescue, emergency medical technicians, and human factors engineers, then proceed to Starliner, opening the hatch. The landing and recovery team begins unloading time-critical cargo from Starliner. The spacecraft is then transferred to Boeing facilities at NASA's Kennedy Space Center in Florida for refurbishment ahead of its next flight. Certainly, Calypso's safe return is a blessing for Boeing itself. Thanks to that, the company will have more evidence to persuade NASA engineers that Starliner is good to go for crew rotation flights once Boeing resolves the thruster problems and helium leaks. Continuing the Starliner program could help Boeing earn $1.9 billion in potential revenue from NASA. Of course, that $1.9 billion is of the $4.6 billion total potential value of its commercial crew contract. As you may know, NASA awarded the company an initial $4.2 billion contract in 2014, and contract modifications since 2014 have added $400 million to the deal. So far, $2.7 billion has been paid out, while $1.9 billion remains to cover future service payments for operating flights. The $1.90 figure is still more than the $1.6 billion in losses the company has incurred on the program to date. $1.9 billion is apparently an attractive number for the troubled plane maker, but at present it would be not easy for Boeing to milk more from taxpayers. There are various large constraints here. To be certified for the first of 6 operational crewed missions, Calypso must be reliable first. Any issues with its propulsion system and even other components have to be thoroughly addressed, but that will be difficult for a contractor known for a decade of persistent technical problems and a flawed operating system. Of course, they really need a major overhaul. And of course, no one knows how long that will take. This is something NASA is concerned about, and the national agency has yet to decide whether to require Boeing to conduct another test flight to ensure safety before officially certifying Starliner for operational missions. Any answer that involves a yes or no comes down to a trade-off between safety and time. Aside from the decision on another test flight to receive a full $1.9 billion, Boeing has to complete 6 missions under the contract. However, only 3 of the 6 missions are currently confirmed to be ordered. Theoretically, NASA awards these task orders about 2 to 3 years prior to a mission's launch. As a result, Boeing can only complete a maximum of 3 missions in 6 years before the ISS retires in 2030. On the other hand, if the space agency allows Boeing to prepare for any Starliner missions beyond the 3 already on the books, this would conflict with NASA's current plan, as SpaceX intends to bring online a new 5th Crew Dragon for its fleet next year. The U.S. Space Agency intends to order more Dragon missions, along with 14 extended missions of SpaceX's Commercial Crew contract. So they just need the handful of Starliner flights already on order, which is enough to keep the ISS fully staffed through 2030. So how about you? Do you think NASA will order more operational missions on the Boeing Starliner? Feel free to share your thoughts in the comments section below. For Boeing, its CEO, Kelly Ortberg, still expresses his commitment to continue work on the Starliner program. He expressed to me an intention that they will continue to work the problem once Starliner is back safely, and that we will have our redundancy and our crewed access to the space station, NASA Administrator Bill Nelson. However, that doesn't mean a long-term commitment. So far, Boeing has not issued a public statement on its long-term commitment to the Starliner program since NASA's decision to end Starliner's crew flight test mission. One more test flight to get a human rating certification could cost about $400 million, based on charges the company booked to redo an earlier test flight. In 2022, the company already had to repeat an uncrewed mission at a cost of nearly $500 million, not to mention the uncertainty over whether the test will be successful. Any additional delay is also a disaster for Boeing's vulnerable budget. Do they ultimately exit the program because it's too complicated and Boeing can't recover its investment because the other guy can do it better? Said Robert Spingarn, an analyst with Melius Research. It could happen. Sometimes retreat is the ideal choice. If I were an advisor to Kelly Ortberg, which I'm not, I'd say, for space. Well, boss, you might want to consider selling it, said Abulafia, an aerospace analyst. The return of Boeing's Starliner Calypso to Earth without its crew was perhaps the hollowest victory in Boeing's history of space exploration. Rather than focusing on the spacecraft's safe landing, what has captured the public's attention most is Calypso's failure to fulfill its role in the crew flight test mission. It carried astronauts to the ISS, but was not allowed to take them home due to safety concerns, leaving the new kid on the block, Boeing's rival SpaceX, to help. Furthermore, Boeing's longtime ally NASA, which has covered up Boeing's mistakes time and again, has ended up embarrassing them even more. The U.S. Space Agency has totally no regrets about the decision to return without astronauts on board. The crack between Boeing and NASA has started since NASA consent to allow both astronauts Butch and Suni to stay on the ISS until February 2025 and return on a SpaceX Dragon. In response, Boeing representatives were later absent in the August 24th press conference, where NASA announced that final decision. 2 Boeing officials didn't also show up at a news conference after the flight without reason. Of course, this is just Boeing's childish tantrum, because they knew full well that their credibility in the eyes of NASA and the public at large was gone. They also realize well that one of the factors being blamed is a severing of communication between those at the top of the company and the people actually doing the work. It's people at the top not understanding what was going on and having no interest in understanding, said Richard Abulafia, an aviation industry analyst at Aerodynamic Advisory. The idea of taking an engineering company and having non-engineers running it with a complete ignorance of technical challenges is a recipe for trouble. It's safe to say that who killed Boeing is the company itself, not someone else. In 1997, Boeing made a history merger with McDonnell Douglas, valued at approximately $14 billion, which allowed Boeing to consolidate its position in the aerospace industry. While the firm had a great aerospace tradition in building airliners, starting with the iconic DC-3, McDonnell Douglas found it increasingly difficult to compete with first Boeing and then Airbus. By the time the Soviet Union collapsed, the company's military business had fallen on hard times, and it had to be very sensitive to costs. Lacking the resources to embark on new product development, merging with Boeing was McDonnell Douglas's way to exit the industry. However, while the firm's name was retired, the McDonnell Douglas management team did not leave quietly. In fact, the tougher, leaner managers of the weaker company elbowed out the more gentlemanly leaders of the bigger company. The result was that Boeing's idealistic engineers ended up being run by McDonnell Douglas hard-bitten veterans. These were were accountants, financial controllers, and other managers, obsessed with cost savings and used to running things on a shoestring budget. They were also very sensitive to shareholder wealth. One money-hungry CEO described those who cared too much about safety and quality rather than the company's stock price as, quote, phenomenally talented assholes. To appease Wall Street and boost its stock price, Boeing has engaged in substantial stock buybacks, spending billions to enhance shareholder value. This approach has been criticized as it diverts funds that could otherwise be invested in safety improvements and technological innovation. It doled out hundreds of millions of dollars on campaign contributions and lobbying to lower safety standards, rake in massive government contracts, and boost its bottom line. In 2018 alone, the company spent over $15 million on lobbying efforts, making it one of the top players in Washington's lobbying landscape. This spending is aimed at influencing legislation and regulations that affect the aerospace industry, often focusing on lowering safety standards and securing lucrative government contracts. To cut costs, the new management approach encouraged extensive outsourcing and a modular design strategy, where a significant portion of design and manufacturing was delegated to external partners. This strategy aimed to reduce costs and development time, but often resulted in coordination issues and quality control problems, as seen in the troubled development of Boeing's Starliner spacecraft. Take the case of its propulsion system, for example, which has failed several times in both the 2022 uncrewed test flight and the first crewed test flight. While SpaceX developed its Draco and Super Draco thrusters internally for Dragon, Boeing took a more traditional path, turning to industry leader Aerojet Rocketdyne for Starliner's various thrusters. In turn, Rocketdyne had its own myriad subcontractors. One of the big differences between new space companies like SpaceX and traditional space companies is vertical integration. If it works well, developing and building one's own technology is faster, cheaper, and much more efficient. Everyone is also on the same team and pulling in the same direction. By contrast, partnerships between two large aerospace corporations are often cumbersome. The need to coordinate across multiple teams, obtain approvals, and navigate different corporate cultures and processes can make even simple tasks like designing a widget an arduous undertaking. Even if a problem does occur, it becomes much more complicated to resolve because this involves a dozen different people in different departments at different companies have touched the part. As a result, it adds time and cost, and no one feels ownership of the process. At a new space company, the process can be much simpler. An engineer designs a part and writes a purchase order for the shop to build it. As an engineer, you're supposed to solve hard problems, but the structural inefficiency was a huge deal, said one person familiar with this process at Rocketdyne and Boeing. Additionally, can't help but mention a poor working relationship between Rocketdyne and Boeing. That relationship was severely strained in June 2018 when the Starliner spacecraft experienced an anomaly during a hot fire test of its launch abort system. Boeing and Rocketdyne more or less hated one another, according to sources. Everyone was in super defensive mode even before this happened. It had been classified as a risk, but the two sides weren't talking openly and honestly about it. In addition to hiring outsourcing, another strategy that Boeing used to increase its revenue is through a cost-plus contract. Cost-plus contracts leave the risk with the buyer, such as NASA, who has little to no control or understanding of the likely or possible overruns. It leaves the buyer open to fraud. A typical example is in the SLS Block 1B project primarily made by Boeing. According to NASA's Office of Inspector General, SLS Block 1B costs will reach approximately $5.7 billion before the system is scheduled to launch in 2028. This is $700 million more than NASA's 2023 agency baseline commitment. However, this approach of Boeing has become counterproductive for the fixed-price contracts. For instance, the contract under NASA's Commercial Crew Program. Fixed-price contracts leave the risk with the seller, for sure, but should also ensure that they carefully assess the program, what it'll take to complete it, and factor in some probable overruns in their costs. The sloppy workmanship and cutting-corner habit of Boeing resulted in bad consequences. As you can see, the troubled Starliner has faced numerous issues and delays in its test flight program, with none of the 3 flights so far being problem-free. Obviously, all the costs of dealing dealing with those problems were paid by Boeing, as required under the fixed-price contract. Boeing has taken about $1.6 billion in charges on Starliner throughout the program, mostly since a flawed initial uncrewed test flight in late 2019. The company took a $288 million loss on Starliner in 2023, including $257 million in the second quarter of last year after the company delayed the CFT mission to 2024. The first crew flight test in June had a minimum mission duration of 8 days. Starliner's return to Earth was delayed to allow time to perform further testing of propulsion system anomalies. As a result of the CFT delays, during the 3 months that ended June 30, 2024, Boeing increased the reach-forward loss on the program by $125 million. In the post-flight to being certified for the first operational mission, Starliner's glitches involving helium leak and thruster need to be handled, and Boeing has to pay for the bill. NASA has not ruled out the possibility of another crew flight test, which could cost its contractor $400 million. Due to financial pressures and the inefficiency of the Starliner program, analysts believe that Boeing is likely to cancel the program in the future. The term Kafkaesque is derived from the name of the Czech writer Franz Kafka, whose works often explore themes of surreal distortion, complex bureaucracies, and a sense of impending danger. It is used as an adjective to describe situations that are confusing, frightening, and often characterized by illogical or nightmarish qualities. Kafkaesque is also a word that Elon Musk has recently used to describe what is happening to SpaceX's Starship Flight 5. Nothing would be worse than when the 5th full-scale test flight of the Starship program has been ready to launch since the first week of August, and the FAA targeted mid-September to determine the approval of a launch license. Out of the blue, there is a plot twist at the 90th minute. The Federal Aviation Administration has signaled to SpaceX that it won't approve a launch license for the next test flight of the Starship rocket until at least late November. It means that Starship's next flight will be delayed 2 months from now. And more comically, the reason driven for the decision seems to be, well, unfathomable. It understands that such a unique operation would require additional time to analyze from a licensing perspective, SpaceX wrote on its website. Instead of focusing resources on unfortunately critical safety analysis and collaborating on rational safeguards to protect both the public and the environment. The licensing process has been repeatedly derailed by issues ranging from the frivolous to the patently absurd. SpaceX said the delays in regulatory approvals for the next Starship test flight have been driven by false and misleading reporting, built on bad faith hysterics from online detractors or special interest groups who have presented poorly constructed science as fact. According to the company, the 2 key reasons behind the delay are the interstage hot staging ring and the landing profile to catch the Starship Super Heavy with the launch tower. These have caused the FAA to request additional 60-day consultations with the National Marine Fisheries Service for the hot stage ring and the U.S. Fish and Wildlife Service for the landing profile. For the ring, SpaceX shared that the only proposed modification for Starship's 5th flight is a marginal change in the splashdown location of the hot stage, which produces no increase in likelihood for impacting marine life. Since Starship Super Heavy will return to the launch tower, it will inevitably create sonic booms, and as a slightly larger area could experience a sonic boom. The FAA has requested additional consultations. According to SpaceX previously released a detailed assessment of why Starship sonic booms won't be dangerous in July, when the FAA had opened up its assessment for the firm's plan to rapidly increase Starship launch cadence in Texas. Additionally, can't help but mention the CNBC's inaccurate article on August 12, wrongly alleging that Starship's water-cooled steel flame deflector pollutes the environment or has operated completely independently of regulation. As a result, the FAA postponed its mid-August public comment sessions on SpaceX's plans to launch and land as many as 25 Starships a year. Hours later, the Texas Commission on Environmental Quality, TCEQ, levied a $3,750 fine on SpaceX for unauthorized discharges, which Elon Musk refers to as silly. In response, SpaceX claims it operated under a multi-sector general general permit and worked closely with TCEQ to implement mitigation measures. They also said the water-cooled steel flame deflector uses drinking water and does not spray pollutants into the surrounding environment. This is confirmed by TCEQ, the FAA, and the U.S. Fish and Wildlife Service. Nevertheless, TCEQ's findings obviously contradict that, and in SpaceX's words, the fine is entirely tied to dissents over paperwork. After reading these, it can be said that constraining the progress of a company by such unreasonable regulations is very unfair. More importantly, this comes at a time when SpaceX is closer than ever to its pivotal test flight. The fifth flight test plays a vital role in the Starship development process, as it will include SpaceX's most ambitious objective yet: attempt to return the Super Heavy booster to the launch site and catch it in midair. To prepare for a singularly novel operation in the history of rocketry, SpaceX engineers have spent years preparing and months testing for the booster catch attempt, with technicians pouring tens of thousands of hours into building the infrastructure to maximize their chances for success. Imagine when we could get to Mars if the pace to build a giant rocket is still faster than paper could move from desk to desk. Apparently, it should not be possible. As Elon said, "We will never get humanity to Mars if this continues." Not only the company itself, but another government agency is also an indirect victim of the bureaucracy. It is NASA. Starship will contribute a lot to the future national space missions. In 2021, NASA awarded SpaceX a $2.9 billion contract to develop Starship's human landing system serving for Artemis 3, the first crewed moon landing mission. This mission has been pushed back from a planned 2025 launch to no earlier than September 2026 due to the hardware's unreadiness. But if the FAA continues to make things difficult for Starship development, it's likely that Artemis 3 and Artemis as a whole will be delayed further. That's unacceptable, especially since we are in the space race against China to the moon. Not to mention, SpaceX is taking a noble charge to rescue two NASA astronauts, Butch and Suni, stranded in space. Without them, I'm not sure the U.S. aerospace industry would have achieved the success it has today. Any government agency should have recognized that not just the FAA, but NASA. Hopefully, NASA will get involved to support its contractor instead of just staying outside expressing its concerns and then blaming SpaceX for Artemis's delay. At this point, you may wonder, why is a company with such a lofty vision, which has contributed so much to the development of the country's space industry, being held back right at home? Perhaps the motivation behind this was not scientific. As you know, no one doesn't want to see the United States win the space race, right? So what's the bottom line here? Elon's involvement in politics has recently made headlines, most notably since he officially endorsed Donald Trump for President of the United States on July 13, 2024, shortly after Trump survived an assassination attempt. Even prior to the endorsement, Trump had considered offering Musk an advisory position if he were to win a second term. Following the endorsement, this possibility has gained traction, with Trump indicating that Musk could lead a new government efficiency commission aimed at auditing federal expenditures. Their partnership could significantly shape the future of U.S. space exploration and defense, as well as shift the balance of power between the public and private sectors in space. It is unclear whether this was the main reason for the increasing attacks on Musk's company, but many people have seen clear connections between these events, and SpaceX's CEO also hints at this through his tweet on September 11th. Unless there is significant government reform, laws and regulations will keep getting worse every year until every great endeavor, from high-speed rail between our cities to making life multi-planetary, is effectively illegal. Trump supports a government efficiency commission to allow great things to be done, but Kamala does not. We will never reach Mars if Kamala wins. Frankly, environmental regulations are often a favorite reason for the effort against SpaceX. The environmental regulations are quite cumbersome, acting as a barrier that could disrupt the launch frequency of most rocket companies. Of course, from the moment Elon started expressing strong political views on social media, he was probably prepared for attacks from opposing forces, so we can hope that he has effective solutions to these problems. So how about you? What do you think about this affair? Don't hesitate to leave your comment in the section below. In October, we will witness a special mission of the SpaceX Falcon Heavy rocket. Given that the workhorse rocket is taking charge to launch one of NASA's most expensive planetary science science missions. Europa Clipper, up to $5 billion, to the distant destination of Jupiter. The Europa Clipper spacecraft will fly by Mars, then back by Earth, using the gravity of each planet to increase its momentum. These so-called gravity assists will provide Europa Clipper with the velocity needed to reach Jupiter in 2030. In a statement on August 28, NASA announced that the mission remains on track, with a launch period opening on Thursday, October 10th. The next major milestone for Clipper is Key Decision Point E on Monday, September 9th, in which the agency will decide whether the project is ready to proceed to launch and mission operations. NASA will provide more information at a mission overview and media briefing targeted for that same week. This is a positive sign for a mission, which was in doubt in July whether it should be delayed. At that time, NASA announced that testing of the transistors showed some were likely to fail in the high radiation environment created by Jupiter's powerful magnetic field. It leads to the challenges of launching a mission in time. NASA said they would determine how many transistors may be susceptible and how they will perform in flight. They were evaluating options for maximizing the transistor's longevity in the Jupiter system. Fortunately, the mission team finally completed the testing of transistors used in the power supply system on the spacecraft. Analysis of the results suggests the transistors can support the baseline mission, NASA said. Europa Clipper is scheduled to launch on a SpaceX Falcon Heavy during a 3-week window that opens on October 10th. The heavy-lift rocket was chosen for its affordability, reliability, and engineering adaptability. NASA, in its fiscal year 2021 budget request, argued that a commercial launch could save the agency over $1.5 billion compared to using a space launch system rocket. Due to Europa Clipper's value and complexity, NASA required that vehicles have performed at least 3 successful launches, including at least 2 successful consecutive launches. Fortunately, by then, Falcon Heavy had flown 3 times, all successfully, although it has not launched since June 2019. NASA's SLS had its maiden launch delayed to 2022. Alternative vehicles with the performance required for the mission, such as Blue Origin's New Glenn and United Launch Alliance's Vulcan Centaur, still stayed on the ground. Furthermore, launching on Falcon Heavy will reduce launch vibration, protecting the payload better. The SLS, a massive rocket, relied on 2 solid rocket boosters during launch, generating significant vibrations. SLS program officials had assured NASA leadership that the twisting load, a measure of the rocket's twist and shake, would be within acceptable limits. However, subsequent tests conducted by NASA revealed a startling reality. The actual twisting load was nearly double the SLS program's estimates. For all these reasons, the agency decided to make the switch to the Falcon Heavy. On the other hand, launching Europa Clipper on Falcon Heavy rather than SLS results in trade-offs on both cost and schedule. SLS would have offered a faster ride for Europa Clipper. An SLS launch would have allowed the spacecraft to fly directly to Jupiter, arriving less than 3 years after launch. With Falcon Heavy, Europa Clipper will make gravity assist flybys of Mars and Earth, arriving at Jupiter 5.5 years after launch. While the time trade-off is not ideal, the agency decided it was the better overall option to select the SpaceX rocket based on the above mentions. For SpaceX and space enthusiasts, it would be better to see Falcon Heavy launch this mission. This will fulfill Falcon Heavy's manifest this year, which is inherently few in number due to the low demand on the market. In 2024, the Falcon Heavy is expected to play a role in a limited number of launches, with only 1 Falcon Heavy launch conducted so far this year, namely the GOES-U mission, which took place in June. This has been opposite to SpaceX's 2024 ambitious goal, aiming for 148 launches across all its rocket families, primarily driven by the deployment of Starlink satellites and other commercial missions on Falcon 9. The Falcon Heavy's utilization is constrained primarily by shifts in the satellite launch market and the increased capabilities of the Falcon 9 rocket. The Falcon Heavy's design is more suited for launching large payloads, but the commercial satellite market is increasingly favoring smaller payloads. As a result, many satellite operators are opting for medium-lift rockets like the Falcon 9, which can carry heavier payloads than originally expected due to upgrades. The Falcon 9's cost of approximately $67 million per launch is also more appealing compared to the Falcon Heavy's $97 million, making it the preferred choice for most missions. Realizing the dramatically rising demand long ago, SpaceX moved lots and lots of optimizations, especially on the Merlin engine engine, which was originally slated for Heavy to Falcon 9 over time. Furthermore, there has been a significant drop in orders for large geostationary satellites, which were once the primary market for heavy-lift rockets. Factors contributing to this decline include the long-term cycles of fleet replacement by major satellite operators and the emergence of new technologies, such as non-geostationary satellite constellations, which do not require the heavy lifting capabilities of the Falcon Heavy. Another reason is the development of Starship. Despite its impressive capabilities, the Falcon Heavy is viewed as an interim vehicle. SpaceX's focus is increasingly shifting towards the development of the Starship, which is intended to replace both Falcon 9 and Falcon Heavy for a broader range of missions, including crewed spaceflight and interplanetary travel. This shift indicates that Falcon Heavy may not have a long-term role in SpaceX's future plans. Nevertheless, for many people, Falcon Heavy never gets old. Each launch of this masculine rocket attracts a huge of public attention, even though 6 years have passed since its first launch, and its number of launches so far is just counted on your fingers. Clearly, its maiden launch in 2018 is a legendary event for many people. The hotel in the area is completely sold out. The parking lots are parked. The reason is very simple. This is not a typical day in Space Coast. Falcon Heavy at that time is the biggest rocket in the world. With 70 meters in height and 3.7 meters in diameter, it consists of 3 modified, strapped-together first stages of SpaceX's workhorse Falcon 9 rocket. Contemporary rockets such as Russia's Soyuz are just 45.6 meters in height and 10.3 meters in diameter. Powered by Merlin 1D, generating more than 5 million pounds of thrust at liftoff. It is billed as the world's most powerful operational booster since NASA's Saturn V. More notably, the separation system that the workhorse rocket uses was something shocking. Elon Musk said before the rocket's maiden launch that the separation system that tosses off the side boosters never been tested before in space, so that's going to be a very big deal for that to work. Even so far, the sight of both rocket sides breaking apart from the core after liftoff has still stoked the viewer's emotions, and the SpaceX CEO is not exceptional. On July 1st, he shared a clip recording that surreal scene on X as a way to arouse pride. The successful first launch of Falcon Heavy was truly a blessing because it then paved the way for SpaceX's new era, where they won lucrative contracts to launch the biggest satellite in the world. Indeed, a year after the successful demo flight, SpaceX signed 5 commercial contracts worth $500 to $750 million, meaning that it had managed to cover the development cost of the rocket, which was more than $500 million. Not to mention, the orders did arrive before the incredible test flight, which belonged to the 2012 first Falcon Heavy launch contract with DoD. The National Aeronautics and Space Administration, or NASA, is an independent agency of the U.S. federal government responsible for the civil space program, aeronautics research, and space research. Established in 1958, it's not exaggerated to say that it laid solid foundations for human spaceflight, beginning with programs like Mercury, Gemini, and Apollo, culminating in the historic Apollo 11 moon landing in 1969. Entering the 21st century, its efforts continue with the Artemis program, which aims to return humans to the moon and eventually send astronauts to Mars. NASA has outlined a specific schedule for their plan, among which is after Artemis 6 scheduled in early 2031. We will do yearly landings on the moon from then on. However, the NASA Inspector General has called the schedules unrealistic. This comes from cost overruns and long-term delays in some projects of the U.S. national agency. Recently, NASA's official Inspector General released a shocking report criticizing NASA's next rocket launcher project for potentially costing more than 6 times its original value, from an original estimate of $383 million to $2.7 billion. In particular, the Mobile Launcher 2 project, or ML2, is designed to support the Space Launch System Block 1B launch and future configurations, which are more powerful versions of the rocket used for sending heavier payloads and eventually crewed missions to the moon. This launcher will be crucial for missions starting with Artemis 4, scheduled for launch in September 2028. In preparation for the construction of this modern architecture, in 2019, NASA awarded a $383 million cost-plus contract to Bechtel to design and build a second mobile launcher. At the time, Bechtel was supposed to deliver the launcher by March 2023. By 2022, the contract value had increased to more than $1 billion, and its delivery date had been delayed to May 2026. Despite the initial cost projections, the OIG report estimates that the mobile launcher could end up costing $2.7 billion and that it would not be ready to support the SLS launch until September 2029. The OIG's projections are based on the cost overruns that have taken place over the past 3 years and the amount of construction that still remains before the mobile launcher is ready. Cost and schedule estimates from NASA and Bechtel have changed several times and increased significantly over time, making it difficult for NASA to identify its funding needs, be accountable to Congress and other stakeholders, and accurately measure project and contractor performance, the report read. The agency's history of increasing the ML2's cost estimate over time also contributes to our assessment that costs will be higher than what the agency currently projects in its agency baseline commitment. So, how about you? Do you think NASA's Mobile Launcher 2 is really worth $2.7 billion? Sharing your opinion in the comment. In response to the report, SpaceX CEO Elon Musk replied, "Holy smokes," as a way to express his shock at the enormous cost and time it took to complete NASA's project. Elon's surprise makes sense because the Starship launch tower has been built relatively quickly and at a lower cost compared to ML2. Indeed, Starship's first launch system just took over a year, from around July 2020 to August 2021, to finalize fundamental structures like the launch mount, launch tower, and Mechazilla arm. Following the maiden flight, additional time was spent, extending over a few months, to incorporate the water deluge system beneath the launch mount. Therefore, based on the experience gained, the construction speed from the second tower onwards will be much faster. This is because SpaceX has been able to rapidly iterate and optimize the design, using its in-house engineering capabilities and manufacturing facilities. NASA, meanwhile, tends to rely heavily on its contractors and made a big mistake in awarding them a cost-plus contract. The main reason for the significant projected cost increases in the ML2 project is the Bechtel contractor's poor performance. The 2022 report made by NASA's Inspector General said, Bechtel underestimated the ML2 project's scope and complexity, experienced ML2 weight management challenges, and experienced staffing turnover and retention issues. In turn, Bechtel officials sought to blame some of the project's cost increases on the COVID-19 pandemic. Of course, delays and cost overruns are common problems on large NASA projects that use cost-plus contracts. Another typical example is Boeing SLS work that, according to NASA Inspector General, will reach approximately $5.7 billion before the system is scheduled to launch in 2028. This is $700 million more than NASA's 2023 agency baseline commitment. Additionally, work being done by Boeing, the main contractor, on the SLS core and upper stages, as well as the rocket's flight avionics suite, is criticized for not meeting international standards or agency requirements. Hardware and cost issues could threaten Artemis 4's September 2028 launch date. Back to the main subject. Some explain that the issues on the ML2 project are unavoidable due to its complex features. However, bear in mind that the SpaceX launch tower is also not less modern. It is designed to support the largest rocket ever built, the Starship rocket, which is intended for a variety of missions, including lunar and Mars exploration. Thus, it needs to reach the required height of around 475 feet, higher than ML2's height. Not to mention, Starship is advertised as the most powerful rocket, with 16,700,000 IBF, nearly twice as powerful as the SLS Block 1B. In the future, along with evolution, it will definitely become stronger and stronger, leaving NASA rockets behind in the dust. Besides, while the ML2 only supports SLS's low launch cadence, the SpaceX tower is designed to accommodate the increasing launch frequency and dense operations of the Starship. Elon Musk even targets to relaunch the vehicle an hour after landing, with zero nominal work. For that reason, theoretically, the Starship tower must be much more robust and modern than SLS's traditional architecture. Amazingly, SpaceX can still optimize its construction phase, saving a lot of time and money. This has set them apart from NASA's other contractors. Not only the mobile launch project, NASA is also having trouble with another problem related to Artemis, which is Orion's heat shield. NASA disclosed months after the Artemis 1 mission launched in late 2022 that more of the ablative heat shield material had been lost during re-entry than expected, but added that it has not posed a safety risk to the spacecraft. NASA is still examining what happened to the heat shield. And that was one of 3 issues that led the agency in January to delay the Artemis II mission from late 2024 to no earlier than September 2025. According to the OIG report, NASA found more than 100 locations on the heat shield where material chipped away unexpectedly during the Artemis I re-entry. The report included images showing pockmarked portions of the heat shield that had not previously been released by the agency. The heat shield material, known as avcoat, wore away differently than NASA engineers predicted, cracking and breaking off the spacecraft in fragments that created a trail of debris rather than melting away as designed, the report stated. The unexpected behavior of the avcoat creates a risk that the heat shield may not sufficiently protect the capsule's systems and crew from the extreme heat of re-entry on future missions. NASA has yet to find a root cause for the behavior of the heat shield material. In response, Kathy Kerner, NASA Associate Administrator of Exploration Systems Development, stated that ground testing successfully recreated char loss and that the material in those tests has the same features as observed on the Artemis I heat shield. But the OIG report noted that while NASA was able to recreate the char loss, they could not reproduce the exact material response or flight environment experienced during Artemis I. In addition to the heat shield char loss, the OIG report said that 3 of 4 separation bolts on the base of the heat shield, used to separate the service module before re-entry, experienced unexpected melting and erosion that post-flight analysis blamed on a thermal model discrepancy. NASA plans to redesign the separation bolt on later Orion spacecraft, but for Artemis II, will install additional thermal protection material in the bolt gaps. Obviously, the work for Artemis II can't be completed until NASA finalizes its work on the overall heat shield. This is a disaster. SLS's most important part, the core stage serving NASA's Artemis II, finally manages to crawl out of the cave after years of dormancy and milking tons of tax dollars dry. We are just more than 1 year away from NASA's Artemis II mission, the first crew mission to travel beyond low Earth orbit since Apollo 17 in 1972. As a mission of the NASA-led Artemis program, Artemis II will use the second launch of the Space Launch System and include the first crewed mission of the Orion spacecraft. The mission is scheduled for no earlier than September 2025, with 4 astronauts performing a flyby of the Moon and returning to Earth. After many years of delay and burning a lot of money, on July 16th, 55 years to the day of NASA's Apollo 11 launch to the Moon, SLS's core stage was rolled out of its manufacturing facility, the space agency's Michoud Assembly Facility in New Orleans. This is where all major structures for every SLS core stage are fully manufactured. The 65-meter booster, with its 4 RS-25 engines, was escorted a mile down the roadway to be loaded onto NASA's Pegasus barge for shipping to the Kennedy Space Center in Florida, ahead of the second mission of the Artemis program. After arrival at NASA Kennedy, the stage will undergo additional outfitting inside the vehicle assembly building. Engineers then will join it with the segments that form the rocket's twin solid rocket boosters. Adapters for the Moon rocket that connect it to the Orion spacecraft will be shipped to NASA Kennedy this fall, while the interim cryogenic propulsion stage is already in Florida. Engineers continue to prepare Orion, already at Kennedy, and exploration ground systems for launch and flight. Currently, core stages and future exploration upper stages for the next evolution of SLS, called the Block 1B configuration, are in various phases of production for Artemis 3, 4, and 5. Many people place the question of why Boeing, the SLS core stage prime contractor, is so slow. In 2019, NASA required the company to accomplish Artemis 3's core stage in 2024, but until now they just have done the second part for Artemis 2. The core stage is the first newly developed stage of the SLS and began to be produced in 2014 under multi-billion-dollar cost-plus contracts. A cost-plus contract is a type of contract where a contractor is paid for all allowed expenses, plus a fee, often 10% due to technical challenges, all but certain to arise. The disadvantage of this type of contract is not to encourage a company to move quickly on a program, especially as businesses seek to maximize profits. This is because the longer a contract goes, the more money it costs, and the greater fees it generates. For that reason, it would not be unfathomable if the contractors deliberately extended their production time. Since 2014, Boeing has begun to experience a number of issues in establishing SLS production that caused significant delays to schedule. A number of fuel tubes that had been contaminated before delivery by the supplier resulted in the decision to reinspect all engine section tubing, which caused a delay of several months. The Vertical Assembly Center, a critical tool in the manufacture of the core stage's propellant tanks, was initially improperly installed, such that the tool was not able to properly lift stage components into position. When the defect was discovered in September 2014, it became necessary to completely rebuild the vac. Later, welding issues encountered throughout 2016 would then cause more issues. Further delays resulted in February 2017 from a tornado strike at the Michoud assembly facility, which damaged buildings and delayed production of the first core stage. Even its test phase, which kicked off at the beginning of 2020, also didn't happen smoothly when facing long-term delays in response to the spread of COVID-19, and then technical problems on both the hardware and infrastructure. As a result, we had to wait until November 16th to see its first flight on the Artemis 1 mission, in which it performed successfully. Can't help but mention, despite the long delay, NASA continued to cooperate with Boeing, and even in 2019 the agency announced that it was negotiating a contract with Boeing to purchase up to 10 SLS core stages, including the mission that will carry the first woman and next man to the moon by 2024. The news release did not mention costs. NASA and Boeing have never been transparent about costs, but certainly production and operations costs for a single SLS launch are well north of $4 billion. In October 2018, NASA's Inspector General reported that the Boeing core stage contract had made up 40% of the $11.9 billion, or $4.76 billion spent on the SLS as of August 2018. Another report in 2021 by NASA's Office of Inspector General showed that NASA will likely spend a total of $93 billion on the Artemis program between 2012 and 2025, and that each SLS launch will cost about $4.1 billion. A large chunk of the budget was attributed to hiring contractors in every U.S. state and more than 20 similar partners across Europe. Clearly, with massively over budget and severely delayed as mentioned, we should have scrubbed SLS to the side, but Congress still wants to save it, leading to the section titled Reaffirmation of the Space Launch System. To say briefly, Congress asserts its commitment to a flight rate of twice per year for the rocket, calls NASA to identify other customers for the rocket, and identifies subsidies to lower the cost of the SLS rocket in order to sell more of them to commercial customers. The administrator shall assess the demand for the space launch system by entities other than NASA and shall break out such demand according to the relevant federal agency or non-government sector, the legislation states. So, if you were the customer, would you want to go with SpaceX's low-cost rockets, which is a fraction of the cost, or SLS with $4.1 billion cost per launch? SLS's issue is too clear. As Elon said, fundamental issue with SLS is that it's not reusable, which means that a billion-dollar rocket is blown up every launch. 100% tragedy. Nevertheless, that number of $4.1 billion will likely decrease a little bit if NASA can manage to study demand for the SLS rocket and estimate cost and schedule savings for reduced transit times for deep space missions due to the unique capabilities of the rocket, according to the Congress. To do that, NASA must also identify any barriers or challenges that might hinder the use of the rocket by entities other than the space agency, and estimate the costs of overcoming those barriers. And the question here is, who will be SLS's potential customers? Previously, a potential customer was targeted, which was a customer in NASA's Science Directorate. At that time, Congress mandated the use of SLS for the $5 billion Europa Clipper spacecraft. NASA, though, later asked for relief from that requirement more on cost grounds. In the agency's fiscal year 2021 budget proposal, NASA argued that the use of a commercial vehicle would save taxpayers over $1.5 billion compared to an SLS rocket. It explains the switch to SpaceX's Falcon Heavy. Another issue is about compatibility matters. Such issues, industry sources say, likely involve the environment the spacecraft would experience during launch, such as vibrations. That environment would be very different for Europa Clipper, a relatively small spacecraft encapsulated within a payload fairing, than for the Orion spacecraft that will be the payload for most SLS launches. Obviously, in today's competitive market, to compete with low-cost commercial rockets, NASA as well as ULA must overcome the big barrier, which is price. This is great pressure for not only the agency, but also the Congress. Anyway, it cannot be denied that Congress's efforts to keep SLS alive demonstrate its steady love of the tall orange rocket. In addition, it is a matter of pride for them to be able to maintain a program that has jobs in every state. To put it into perspective, Starship is nearly 30 meters taller than the Statue of Liberty. The most popular reason for this is to carry more payload to remote areas such as the Moon and Mars. Also, there is a less famous one that could raise some eyebrows, which is to raise the success rate of the whole mission, and this was confirmed by NASA experts. It appears to be weird because the increased surface area on the larger rockets tends to make more aerodynamic drag, increasing the energy required to overcome atmospheric resistance. Additionally, the larger size is proportional to operational complexity, especially in terms of payload integration and launch procedures. So why did I say it will benefit the mission's success? Okay, let's discuss an upcoming critical mission on Starship Artemis 3. One of the greatest challenges of the mission is the orbital refueling technology, involving the number of tanker flights required to complete Artemis 3. This has been hotly debated since 2021 when NASA awarded SpaceX a $2.9 billion contract to build Starship HLS. Given that at that time, the Government Accountability Office noted that SpaceX required 14 tanker Starships. Elon Musk spoke up to disagree with the idea of 14 flights, though. He said at least 4 or max of 8 tanker launches were needed to fill 1,200-ton tanks of the lunar Starship. Even now, the SpaceX CEO still doesn't change his mind. Evidently, while the lunar lander climbs its propellant load from 1,200 to 1,500 tons, Starship has also been planned to evolve into its third version, with more than 200 tons of payload capacity, doubling that of version 2. To add further certainty recently, he tweeted that Starship 5-3 should be capable of close to 200 tons of payload when operating as a tanker. So to meet HLS's need for 1,500 tons of fuel, we only need 8 tankers, keeping up with Elon's goal 3 years ago. Maintaining the number of launches at an appropriate level not only saves cost, but also benefits the overall mission success rate. Let's look at the probabilities table made by former NASA administrator Mike Griffin, calculating the probability of success for a multi-flight refueling campaign. It reflects the correction between the reliability of one operation and the number of operations. To put it simply, we can understand that the more times a rocket tanker launches, the lower the entire mission's success rate. Take, for example, assuming that each individual Starship launch, plus the subsequent propellant transfer operation, will have a 99% probability of success once the procedure is refined. If 5 tanker flights are required, the mission as a whole will succeed in 95% of scenarios. If 15 tankers are launched, the rate will go down to 90%. The rate even will drop dramatically if the numbers in the reliability of one operation column decrease. As a result, with 8 tankers, SpaceX can ensure the whole mission's success at the highest possible level. So, of course, to accommodate that 200-ton payload, SpaceX had to increase the size of the Starship's tanker variant. Based on the previous analysis of the account, namely Starship fairing, and Elon's latest announcements, we can come up with some speculation as follows. To extend the propellant tank volume to the maximum, the forward dome will be removed, while the common dome moves up. Thanks to that, Starship can hold up an additional 75% of propellant at launch. In addition, its diameters could be expanded significantly. In 2016, SpaceX had a 12-meter diameter and 77.5-meter high ITS rocket design instead of a 9-meter wide and 50-meter high version today. It was designed to launch 300 tons to orbit and with refueling could launch 450 tons to Mars. The ITS was about double the volume of the current Starship Super Heavy, but had 3 times the payload. In 2019, Elon revealed the 18-meter diameter Starship 2.0 is as twice wide as Starship's current prototype. If the Starship 2.0 had similar scaling to ITS, its height would be around 116 meters. Then it would have 9 times the payload of the Starship. However, according to Tovera Vicini, rocket height is limited by thrust per area. This makes sense, as you can see through 3 Starship versions. Although the V3's load is twice the V1's load, V3 is just a little bit higher than V1. Besides, the payload capacity may be correspondingly deducted to compensate for the added rocket weight due to many upgrades on Starship. For that reason, it can be said that ITS's initial sketches may no longer be appropriate at present. This means that with such a diameter, the parameters including height and payload capacity would be smaller, and my guess is that Starship 5-3 will be designed to have a 12-meter diameter. Not only that, in the future, SpaceX plans to push the boundaries even further by making Starship's payload capacity quadrupled. Starship will eventually be 492 feet tall, roughly 20% higher than the current massive system aboard the Super Heavy rocket. The Super Heavy booster is expected to hold up to 4,100 metric tons of propellant, and Starship up to 2,600 metric tons. The maximum liftoff thrust is anticipated at 103 meganewtons. Despite SpaceX's attempt to scale up Starship to meet the common humanity target, there is still skepticism about its feasibility. Firstly, can't help but mention SpaceX's arch-rival, ULA, with allegations that the additional growth of the Starship launch vehicle will cause the environmental and safety issues greater than the current prototype in Starbase. In addition, they criticize SpaceX failed to keep up with what Elon Musk said, given that the current version of the Starship may not reach more than 100 tons on version 2, let alone the 200-ton payload mark. As a result, SpaceX is still very far from its goal of colonizing Mars. Furthermore, ULA points out that refueling Starship HLS during Artemis 3 and even beyond missions will require a higher number of tankers than expected. Throughout ULA's article, we can see clearly that, like Blue Origin, ULA is just seeking to play dirty on SpaceX because its arguments mostly are not reasonable. Starship's current prototypes are just used to service SpaceX's testing philosophy: test, fly, fail, fix, and repeat. So, the fact that it has not been perfect in the first place is very normal. Moreover, orbital refueling technology is difficult, and SpaceX is only in the early stages, but its achievements in Flight 3 with this technology are off the table. Even NASA also confirmed that. At least SpaceX has been running around the clock to speed up Starship's progress, while ULA sits there and talks like it's the best rocket company in the world, even though it has just been hit with financial penalties for delays to its new rocket, the Vulcan Centaur. Secondly, Gao's June report, again, placed Starship HLS into the hot seat for interrupting NASA's efforts to return to the Moon, given that it potentially pushes the mission to February 2028. More strangely, it just focuses on SpaceX, without considering other aspects such as SLS, Orion spacecraft, and the new lunar spacesuit. It is worth noting that NASA is also showing helplessness with more than 100 failed positions on the Orion heat shield. And if NASA continues to do that, Artemis 2 also will be delayed to no earlier than September 2025. And the following Artemis phases will have the same fate under the domino effect. And that just about wraps it up for today's episode. Thank you, and we look forward to seeing you next time.